Hi everyone, my name is Katie Pop and I'm doing a public lecture review of Dr. David Hu's lecture on wombat poop and animal feces slash urination. So I learned a lot that I didn't really know before, or learned a lot about things I never really thought I'd know about. So that was pretty interesting. This was the first lecture of the semester and it was a couple weeks ago, so I'm trying to remember a lot of the things that I learned during that time, but I wrote down some notes as I was watching the lecture. So in terms of things that I learned that I didn't know before, I learned that there's not necessarily a relationship between animal size and like urination time. It's normally like around the same average for all animals. I think Dr. David Hu said it was like around 20 seconds for all animals, and that was because the time it takes for the urine to leave the bladder doesn't really depend on like the volume of urine. It's more like the height, or like the height of like the tube that you pee out of. So sorry if that's not technical, but yeah, I think those are the words that Dr. Hu used. And also I learned that larger animals have a faster volumetric flow rate of feces, and that's because of like more slippery mucus in, I'm not going to say the word, but yeah. So overall, I learned a lot about poop and feces and the physics of these kinds of things, like volumetric flow rate and like the pull of gravity like on urine as it flows out of your body. What did I learn that I already knew? I think I knew a bit about like volumetric flow rate and the fact that it didn't really depend on, or I'm sorry, I learned a lot about like the pressure of urination doesn't necessarily depend on volume. It's mostly like how tall the barrel or like container is. I learned about that in like fluid mechanics. I'm a civil engineering student, so we have to take that class as a prerequisite for a couple other classes. So I learned this in my fluids class. So I didn't realize that it applied to animals or like urination, but yeah, I guess it does. So that was pretty interesting to learn that I already knew. And in terms of things that sparked my curiosity in this lecture, I was kind of interested in the application of, I guess, the studies of like poop and feces in animals and how it could maybe apply to like climate change studies, just because like methane gas is emitted from the feces of livestock, and that's like a huge contributor to greenhouse gases. So I was thinking like, how can we use this information about like volumetric flow rate of animal feces and use it to like, I don't know, calculate, I guess, the carbon footprint of like a farm, depending on like how many animals they own and like what kinds of animals they own. I thought that could be interesting because maybe that information could be used to like sort of change a public's view of like a certain farm. So if you live down the street from a farm that has like a huge carbon footprint, you know, it's kind of change like your view of that farm, and maybe give a more negative outlook on like the meat industry, because that's a huge contributor to climate change, or I'm sorry, to greenhouse gases. So I thought that might be kind of interesting to look into. And the next question is, did this somewhat relate to your area of study? I'm a civil engineer. We do a lot of like physics in terms of like force balance and stuff like that, but I took the one class in fluids, and I think that was the only thing that like this could have applied to. I'm more aiming towards like structural engineering or like planning, and so this doesn't really have a role in that, but it is really interesting, especially because I learn a lot about like environmental engineering through just the civil and environmental engineering school in general. So some of my classes talk about like contamination, and Joe Brown is in the civil engineering department, and Dr. Hu mentioned Joe Brown as like a collaborator on this project. So it was really cool like seeing how the civil and environmental engineering department can use information on like animal poop and urination, and for I don't know, good purposes, I guess. And then did I follow up on this topic outside of lecture? Yeah, I looked at the Ig Nobel Prize sort of award, I guess, and the requirements for that, or the just like what kind of projects are highlighted in the Ig Nobel Prize. And actually, one of my teachers in a global engineering management class had mentioned this like a few days before the lecture, so I kind of knew what it was beforehand. And so we read about that piece that Dr. David Hu was talking about in his response to the senator, I guess, that sort of trashed on his work. And so from like a communications point of view, he did an excellent job, like sort of defending himself and finding a way to like acknowledge the senator's criticism, but also defend himself in a way and say, like, you know, this kind of science is needed, whether it's needed for the public's purposes or for like this individual like problem that we're working on in like this country or another country. It's definitely needed. And then also I mentioned that Dr. Hu mentioned Joe Brown in the lecture too, and he's a civil and environmental engineering professor, as I mentioned before. And I've heard a lecture from him about latrines in developing countries and how that's like improving hygiene and health. And so that's definitely related to David Hu's lecture, and just sort of learning about like contamination in like developing countries, like where's the contamination coming from? Is it from animal poop or from human poop? We don't know, but this would be cool to like find out from a collaboration between these two professors. So yeah, thank you so much for listening to my review. I thought this public lecture was really interesting. I was kind of grossed out a couple of times. Honestly, more than 75% of the lecture, I was pretty grossed out, but it was really interesting and fun to learn about how we can study things like poop and how it can be really helpful for us to understand like other things in terms of like wombat, like cube-shaped poop. Like, how is this going to apply to like manufacturing? If boxes are coming out of like a tube shape, like how can we make that happen? So yeah, thanks again for watching.